Hi, everyone. Thanks for coming back again. Today we're going to do Ken Shoulders number 33, which is very cool. And I've got a few things that I wanted to talk about before we go into the reading. Today's really going to be about the monopole. And so we're going to kind of go into some of that. And then we're going to have Brandon read a really awesome paper that was connected to some of the references that I found with some of the other Ken Shoulders papers. There was a Yes Mates, I think the guy's name was, and there was one paper that I'd found that I think we read through, and then there's a reference to this other paper, and it's all about monopoles. So, Brandon, if you want to start sharing, I'll do my reading part, and then we'll have you carry on. Yeah, so this is something that I wrote, looks like March 11th of 2024, and it's the Turing wave. And this is basically the Turing wave is the basic building blocks of our reality of this universe essentially. And we are going to talk a little bit about how you can alter it to change, do teleportation, do time travel. All of these technologies kind of relate back into the subquantum, back into this Turing wave. So the Turing wave is a dodecahedron standing wave pattern that inverts on itself and vibrates between space-time, where you have three dimensions of space and one of time, which is where we are, and time-space, which is sort of the other side of this Turing wave where it oscillates back and forth. And so time space is three dimensions of time and one dimension of space. And those three dimensions of time really allow us to do some really cool things with technologies, like I was saying, teleportation, time travel. We'll get into that a little bit more. So everything in our universe emanates from a single point, which is the Turing wave. So essentially, every time the Turing wave oscillates between us, which is space time, and then it goes back into time space, that's one blink of the universe. And as the Turing wave, and the thing that's important to understand is every single Turing wave in our entire universe is blinking at the same time, so that everything is in phase. And when that happens, essentially what happens is it creates the Akashic record, so that the the Ed that was here 5 minutes ago is still here. All we need to do is be able to access that Akashic record by going back and time traveling back to that point. So essentially, what I'm trying to say is even our bodies are being recreated every moment by moment, essentially by this Turing wave. So it's basically the main building block of the universe, essentially. And this is all from Paul Laviolette's Subquantum Kinetics, essentially. So let's see what else we got, Brendan. Okay, so how does the Turing wave form, or what forms the Turing wave? Well, this is something I wrote on March 2nd of 2024, and these are not my words. I thought, if we want to learn about etherons, then we need to go right directly to Paul, because Paul's theory of subquantum kinetics, etherons are actually the very, very smallest thing that we have. And it turns out that these etherons are what actually form this Turing wave. And it takes about 100 billion etherons, more or less, to form this Turing wave. And what's interesting about all of this is I remember talking to Chris Beskar about it one day and saying that I thought that an etheron, a charge cluster, and ball lightning were all one and the same. They're just all fractals of each other as you move up the fractal tape, essentially. So the etheron itself is the smallest thing, and it takes about 100 billion of these to form this Turing wave. Well, what's really interesting is from Ken Shoulders' research into charge clusters, or exotic vacuum objects, as they're also known as, it takes about 100 billion of electrons to form a charge cluster. So there's this fractal thing moving up the fractal tape again. So the definition that Paul Laviolette himself gave of an etheron, and this is really important because this actually comes right down to consciousness itself. The subatomic particles and photons, which make up our physical universe, are themselves modulations of the ether substrate. So they're basically part of the ether, i.e., wave patterns made up etheron concentrations and vortical etheric fluxes within particle cores that give them property of spin. So it is all about spin, and Paul, knew this. And this is the important part. So if we regard etherons as conscious entities, and I think that's the most important thing to pick up on here is the fact that it starts with these very, very, very small structures who are actually, that's where consciousness lies essentially. And then as we move up the fractal scale again, these little etherons are doing various jobs like they are the chemical bond. We know from Solomon, some of Solomon's work in his PhD, that these etherons are actually that form the chemical bonds and so on as we move up there. So for physical form in subquantum kinetics is merely a manifestation of an epiphenomenon, and I actually had to look that up and learn what it meant, generated continuously by the ether flux. And this is Paul Laviollette's thing. Epiphenomenon, a secondary effect or byproduct that arises from but does not causally influence a process. So that's his sort of definition of it. And then on the next one, Brandon, I wrote, and this is all my theory, of course. February 5th of 2024, I was writing about the Turing wave, and I said every single thing in our universe has one thing in common, and that's the Turing wave, because it's basically the building block. And like I said, every single Turing wave flash is all coherent with all the other ones in the universe, because if they're not coherent with the ones that are in our universe, now we're going to time travel, or we're going to do teleportation, all of these types of technologies. So I said, could the Turing wave be the glue that holds everything together? And in some ways it is. And this is love as we know it. So the Turing wave is source, just tuned to our frequency, which is the Turing wave in our universe. So this right here is a dodecahedron, and this is actually the shape of the Turing wave, the standing waveform that gets set up by these etherons. Now, what ends up happening is this is what it looks like in our universe in space time. But in time space, when it oscillates back into time space, this thing actually implodes on itself. And then when it comes back out into space time, it explodes again. So it's an implosion explosion kind of thing going on, essentially. So that is the structure. And there's 12 faces. This has 12 faces, and it's got pentagons. So it's a pentagon with 12 faces. And there are, we know from Elena Danon's work and others, we know that there are 12 densities to this universe. So if we were to go into a different universe or a parallel dimension, the Turing wave may not be the same, and indeed is not the same. Again, from Elena's work, we know that the Anunnaki universe, for example, that the Turing wave is got a structure of not 12, but it's actually got a structure of 15. So its structure is 15, and then source is one above that. So source is at 16. So in our universe, we have this dodecahedron, which is 12, and one up from that is source, which is 13. So that's how it works in our universe. So what else have we got here? So the Turing wave is source just tuned to our frequency, which is the Turing wave in our universe. When source is tuned to a different frequency, then this is in a different universe among the multiverse. The Turing wave's the heartbeat of source at our frequency. That's kind of how I look at it. It's the pulsing of this Turing wave that's all in synchronization or in coherence with everything in our universe that allows us to be part of this dimension essentially, because if we were blinking or pulsing slightly out of phase, then we would not physically probably be here, or we would maybe have abilities like these guys that can actually use their consciousness to walk through solid objects. And that is something that the US government actually did indeed test and go through. Maybe we'll jump into that at some other point. So let's go with the next one, Brandon. And these ones are all important to know that the rest of these screenshots that I'm going to show you are all from David Wilcock and Chris Beskar at Stavati Aerospace. This is stuff that I've had for about 4 years now. And it just turns out that this was the point to bring it out. So it says the pineal gland creates an EVO, exotic vacuum object, also known as a charge cluster, every time you fall asleep. So that's something interesting. And the thing about it is that we in this group have been talking about these charge clusters in the terms of energy, because essentially what they are is they're little packets of, or sort of like a container for this energy. But the other thing is that these charge clusters are also containers for information. So that's what this is more talking about, is the information side of things, where the consciousness lies essentially, right? So what else have we got here? Yeah, as you breathe into a meditation, your EVO gets more and more powerful. And this is something that we know, that this science is nonlinear. So it starts out kind of slow, and then it builds up and builds up and builds up, and then it really builds up and builds up. And that's kind of basically what this is saying. As you meditate, you're taking this EVO or these EVOs, and they're allowing you to meditate even better, essentially. And it is totally nonlinear. Yeah. What else we got, Brandon? Okay, so this relates back, because we are going to talk about the monoatomic, or sorry, the this is from Bob Greenyer's work, actually. Sorry about that. This is called the D4D, and what it is you have the main toroid is the D, and then you have the 4D, which are the little toroids that are spinning at 90 degrees to the big one, and that's the 4D structure. And this is essentially from Bob Greenyer's work. He's done some great work into charge clusters, and I think in the next slide we're going to see, you can go to the next one, we're going to see the actual structure of what it looks like. Okay, no, okay, so this is the monopole. So let's talk about the monopole a little bit. Essentially, this is something, I guess, in physics that's kind of the holy grail in a lot of ways. We know from Ken Shoulder's work and some of the Russians' work, plus Bob Greenyer's work, that the monopole is a true thing indeed. And this basically shows it very well, where we have spin on the top down and spin up at the bottom. And in the middle, you sort of create this null zone, essentially, where all the magic kind of happens. And this is essentially what they call the monopole. So if we keep going, Brandon, let's see if I've got a different thing here. Yeah, so this is something that came out of Ken Shoulder's research, which is the top part that Brandon's going to read. And then the bottom part is from Russian research. But if you can maybe make the figure bigger, Brandon, just the drawing itself bigger, just because just want to show people. Just expand it, so yeah, so we can see the, yeah, exactly. So what you end up happening or seeing here is, again, you see that D4D structure, where you've got the large toroid or torus around the plus and the minus, and the plus and the minus, again, is that null zone, essentially, what ends up in the middle. And here you have the D and then the 4D structure with the blue ones that are rotating at 90 degrees. And essentially, charge clusters, that's what it is. We're spinning things up a tremendous amount. So this is stuff from Russian research and stuff that Ken Scholer's looked into, but it also applies to exactly what we just showed you with Bob Grenier. So essentially, we're saying that, Bob is on the right track as far as Ken Scholer's work and the Russian work. So Brendan, maybe you can make it smaller again, and then we'll have you read the top and the bottom.
Okay, so by some irony of fate, we may have folded back upon ourselves. This is Ken Shoulders reading. Now
Yep.
have accidentally discovered the EV, or the electrovalidium, or
I'll just stop for a quick second there. Electrovalidium was the earliest name for EVOs or charge clusters. There are different names, and that was, something that Ken used originally. It means strong electron, actually, I think is what he electrovalidium. So sorry, Brendan.
discovered the EV as an ideal monopole oscillator. This oscillator is the perfect generator for vector and scalar potential waves without contamination from either electric or magnetic fields, E or B
Yeah.
fields.
Yep.
These waves can be thought of as longitudinal waves in the vacuum, are largely undetectable by standard electrical E and magnetic B detecting means, but are readily accessible to the monopole world. There appears to be an incredibly large number of useful phenomena yet to arise from, you can hear me okay?
Yep. You betcha.
Yet to arise from using potential effects that are not immediately accessible to the force of electric and magnetic fields. This phase-determined force-free world will certainly be another chapter somewhere in the future. Ken Shoulders, EV, A Tale of Discovery.
Yep.
So let's just make this a bit bigger.
And that EV, A Tale of Discovery is Ken Scholer's book. That's something that I is going to be coming up very soon with in the group here. We're going to start going through all of his stuff. And this thing here is from the Russians.
Okay, figure four. Is that figure there, Eddie?
Yep.
Yeah. Okay, figure four, non-radiating configurations. Such configurations consist of a toroidal dipole represented by a solenoid with oscillating colloidal currents and an electric dipole represented by a pair of opposite charges oscillating on the same frequency as the currents. With appropriate phase difference and oscillation amplitudes, destructive interference takes place. The combined source does not radiate electromagnetic fields. However, scalar phi and the vector a bar or a bold potentials associated with radiation of these dipoles do not cancel, but instead propagate to the far field. Hence, a non-radiating configuration acts as a source of electromagnetic potentials, but not electromagnetic fields. The physical significance and detectability of these potentials are not established, but are being actively discussed in the literature. Okay, so let's just do that. And bottom it says Apis I Marcus and Fedotov. I can't pronounce these. They have to use
Yeah. Yeah.
2016 electromagnetic toroidal excitations in matter and free space. Nature materials, so that's one of nature's subsection of nature, probably.
Yeah.
50, volume 15, page 230, 263 to 271, 2016. There's the
Yep.
URL for that. Okay.
And again, that slide originally came from David Wilcock and Chris Bescart Stavati about 4 years ago, back in the day. Now, this is pretty interesting because I've talked about this before, and I'll say it again here. Is I think it was like the second or third interview that I had with Chris Beskar. Maybe it was the second one. We were talking about the Ken Shoulders patents, and Chris mentioned to me that he had them and he would send them to me. So what ended up happening was he not only sent those, but he sent a whole huge file full of things. And what I did is I'm not one to look at stuff on the computer very much. I need to have it printed out. So I sent it out to the printer that I have in town here, and it was over 600 pages. And they made a mistake kind of because they only printed it on one side. So it was a huge stack of papers like that. And I couldn't really carry it properly. So the girl at the place, she found a box and she split the pile into two and did that. And then I carried it home and I brought it in and I decided to put the two back together, the pile back together. And what ended up happening was this one, this particular paper fell out on the floor, and it fell out. And I looked at it and I went, "Oh my God, I've seen that structure before." So, and I'd already had screenshots of these structures from Bob Greener's work and from other places. So what I ended up doing was like, oh, okay, well, I'm going to put a whole sort of file together, and I know that I've shared it with you guys in the group before. This very thing. So that's kind of what happened. But this is actually this can be considered the D, the big D, the big torus, and then it's more than 4D because what you end up having there is those are charge the big ring, and then you have other rings that are going in 90 degrees all the way around it. So this is actually a charge cluster.
Toruses within toruses.
Yep. Or yeah, exactly. Toruses within toruses, or yeah, rings within rings, and they're all rotating and moving at the same time. Essentially, this is essentially what a charge cluster is. So this is a computer model, I believe, that Ken Shoulders would have developed. I'm not sure exactly where. And then I think if you keep going, Brendan, we're going to see the same structure. Okay, this one. Okay, this is a cool one. I think there's another one that I'll talk about. So this is John Hutchison, and this re-index of exchange Ken Shoulders, that was the huge file that Chris Beskar sent to me. Now, John Hutchison never knew, he knew about Ken Shoulders. They were good friends, but he never knew about Stavati Aerospace or Chris Beskar because it was all kept classified for almost 30 years until I started bringing stuff out to the public. So this is, um, I found out that John's dog's name was EVO. So I asked about EVO the dog, and they actually said it was really funny. It was Nancy and John said that it was the only name that the dog would come to. They had tried other names, they named it other things, and the dog wasn't responding. So then one day they said EVO, and the dog came. So thank you, most appreciated. Yes, EVO was named after Ken Shoulders. I first met Ken in 1995. He would visit me, stay a week later. Then I visited with Ken in various locations. Thank you lots. That's something that John always puts down. Thank you lots, which is very cool. Best John Hutchison. So John and Chris Beskar. I'll announce it now. John and Chris Beskar are going to meet each other on Technology Envoy in the next couple months. I've set up things so that they can meet each other because again, John didn't know about Chris or Stavati. He knew about Ken Shoulders, but he didn't know that there was a business relationship between Chris and Stavati to use all of the Ken Shoulders research into charge clusters to make all this technology work. So very cool. What else? And that I don't know what it is. He sent me that. It almost looks like it could be an EVO gun, actually. And I know that he has produced things like that before. So, and there's two of them I see also, actually. So that's interesting. But we'll ask him more about it, what that is exactly. Okay. All right. So now we have an awesome paper, again, that was, I found it by going back and looking at some of Ken Shoulders' papers and getting references and so on. So I'm going to let Brendan read this, and it's all about the monopole again.
Sorry. Okay then. Um, I'm just going to be back in about half a minute. I just need to go to the restroom a moment.
Okay, sounds good. Yeah. Um, yeah, so electron clusters, that's another name, I guess, that you can use. Charge clusters is the name that I first learned about. Um, it was Carmen's father, Bill Mueller, who actually saw the Nazi flying bell at Peenemünde, which was the German secret space program at the time. And he knew that charge clusters were responsible for what was going on. But when I met him in 1980, we also knew not to talk about charge clusters at all, essentially. That was one thing that he kind of instilled in me. And I never really talked about things up until probably a couple of years ago when I was in another group. And we started talking more and more about charge clusters, and then eventually got into meeting Chris Beskar and then finding Ken Shoulders' research and going through it and whatnot. So there are various names. It started as, like I said, electrovalidium, which Ken had called the strong electron, and then after that, charge clusters is another name. But the real name, the technical name, I think that everyone is probably using or should be using is EVO, which stands for exotic vacuum object, essentially, and that's what Ken basically called them, and that's why John named his dog after essentially Ken's EVOs, which is really cool. All right. Well, we have Superman coming back here.
Okay, so that's the when I take this t-shirt off, I feel like Clark Kent. Anyway, okay. Electrons, clusters, and magnetic monopoles. Ramboat in France, from France.
Yep.
It is shown that there does exist a possibility of producing bursts of magnetic monopoles using properties of largely ionized dense media, where electron and accumulations or clusters are used to form. A spontaneous gauge or gauge symmetry breaking occurs when the electrons constituting cluster are sufficiently close together for opening way to the creation of topographical effect, which, as it is known, has in this case the properties of a magnetic monopole. Those properties of magnetic monopoles bounded in this way in the frame of quantum theory of fields are not contradictory with the initial concept proposed by Dirac. But conversely, complete. So Dirac was he's mainly active in the 1920s and 30s from Cambridge. He was kind of a lot in particle physics anyway.
Mm-hmm.
But conversely, complete this model showing the possibility of producing monopoles and to observe them in laboratory with relatively low energy devices. Introduction. Electrons accumulation or cluster is a macroscopic entity put into evidence, firstly in Russia by G.A. Nasyats, reference 1, as early as during the 60s of the 20th century, which he named Pton. Secondly, in the United States, during the 80s by Ken Shoulders, reference 2, and named by Latin words electron validium, strong electron. According specific According to specific experiments, the shape of an electron's accumulation, spherical and a typical cluster of radius 3 micrometers, may contain as many as 2 times 10 to the 10 electrons. For performing Coulomb barrier screening and obtaining DD nuclear fusion, DD, is that deuterium?
Yeah, I don't know what they're, yeah.
D-D nuclear fusions, some 10 to the 3 or 1,000 electrons may be sufficient, reference 4. The mean distance between electrons in the cluster is typically in the range of electron Compton wavelength, 2.426 times 10 to the, I think that's the minus 12
Yep.
meters. The most typical way of obtaining electron clusters seems to have been the use of rough surfaces of electrodes, the discharge vice, reference 1. For accounting the transitory cohesion of electron clusters, it seems sufficient to take into account the interaction between the spin of electrons, another cause such as the Casimir effect, seeming to be ruled out. Reference 5. Electron clusters seemed first to be only interesting for their great energy density, the capacity they have of producing screening of two colliding charges, I think means colliding charged particles, open the way for a new use of those macroscopic entities, physics experiments, reference 4. It seems that the role and efficiency of electron clusters is being progressively recognized as being primordial in low energy transmutation processes. In many experiments, for example, which are known as not involving any thermonuclear process, but leading nevertheless to fusion reactions, one can invoke the role of electron clusters as being primordial. But in some experiments, when photographic emulsions were used, strange tracks appeared when their large transversal dimension and their length. It could correspond to any charged particles. First who has proposed officially that those tracks could be due to magnetic monopoles is L.I. Uskov, Tau, reference 7. Experiments were successfully reproduced in 2 other laboratories, reference 8 to 11. Given the shape of those abnormal tracks, they were called caterpillar in a picturesque and vivid way. Some years before, there was at least one experiment where similar tracks were observed, curiously called also caterpillar, without any mention of magnetic monopole by I dash et al. Reference 12. Experiments consisted of making nuclei react in a glow discharge chamber, plasma being rich in electrons. Those experiments were in fact very close to the ones of L.I. Rustov. I can't pronounce that, sorry.
Yep. Me neither.
Consider them from the point of view of electrons accumulation, references 5 to 6. In another term, in other terms, there was exist several laboratories where it seems that the same phenomena has been observed separately. A particle track having the shape of a caterpillar in a film. Magnetic monopoles production in plasmas becomes a heuristic hypothesis. Process of electrons cluster formation. There are many ways of creating electrons accumulations. The life of those accumulations is typically comprised between 10 nanoseconds and 10 microseconds. For example, G. Messiat's makes a rough cathode which produces bursts of electrons owing to the roughness of this cathode. But there's another method which consists to create from a plasma a LPS, large quantum system. According to the terminology of Eli Pigogene, a lot of various resonances occur in an LPS. One has to emphasize that the expression LPS was made up initially for energies at the atomic level, seems well suited for larger ones, typically some a killer electron volt, to some tens of a killer electron volt, perhaps of. This way is precious in the case of monopole creation, as is shown further. Given the LPS distance, charged particles, this is atom nuclei and electrons, can be considered as being quasi-free. A 3D distribution is ruled by Poisson's law. Thus, the p lowercase p to the p probability for a microwave, for a microvolume V containing p nuclei and mu being the mean number of nuclei per V volume, reads E underscore P equals E to the power minus mu in brackets mu to the P over E. What's the mathematical thing for this? What name for this? I've forgotten the name.
I don't know
I
actually. You
can't,
mean the
remember
exclamation mark?
the exclamation mark. I can't remember the mathematical term.
Yeah,
Anyway,
that's okay. Yep.
equation one. Considering the V volume, V microvolume leads to evaluate the order of range of the mean factorial. It's P factorial, that's what it means. Okay. The order of range of the mean number of trapped electrons nu around two colliding nuclei. Interesting sites of this distribution are the ones where it occurs two nuclei collisions. Probability of finding two nuclei in the V volume reads P underscore 2 equals e to the power minus mu in brackets mu squared over 2 factorial close brackets, equation 2. Given the high electron mobility in comparison with the one of nuclei, coming closer of two nuclei builds a small potential well, which prompts transitory electron accumulation, reference 4.
I'm just going to stop you for 1 second there because that small potential well is exactly how subquantum kinetics looks at things. We're looking at hills and valleys essentially, or a well essentially. And Ken Shoulders does talk a little bit about that as well. So sorry, Brandon, you can carry on.
So, and the ratio between the probability of filling a V microvolume, one unique nucleus, and the probability of filling it by two nuclei is equal to the number of electrons nu surrounding two colliding nuclei. Its distance is inferior to the 4-atom radius. Nu equals 2 over mu. This model, primitively built to account for non-thermonuclear fusion reactions in a plasma, seems to be pertinent other technical processes which put condensed medium to condition a cold wave, figure 1.
Yeah.
Number 1, cells for cold fusion, Fleischmann and Pons, 2 beams of d to the power of 2, d to the power of 2O. I think is that deuterium or something? Deuterium oxide or something, I don't know what that is. Beams of d to the 2O impinging on a metallic target filled with D nuclei. Brookhaven National Lab during the 80s. 3, force currents through a condensed and deteriorated medium NRL during the 80s and 70s and others. This model is grounded. Let's take a bit of a break. This model is grounded on two specific peculiarities, reference 4 to 6. A, use of specific dimensional relationship replacing the Lawson criterion, which is only valuable for the thermonuclear process. B, the fractal dimension of the two nuclei colliding space, reduced from use of the Poisson statistic. Moreover, this model is not restricted to fusion reactions, as it is in agreement with most low energy transmutations. For example, those which have been put into evidence in experiments performed in the Port of Institute, reference 7 to 11. Figure 1 on the y-axis, it looks like Tesla's, I think, Tesla's meters. I can't see make out the thing there. So, and on the y-axis is electron volts. Figure 1, representative points of typical non-thermonuclear experiments showing the specific place of cold fusion. Each straight line corresponds to a specific electron number. Monopole creation. One has to underline the difference with the customary theoretical thought processes about magnetic monopole problem. In our case, one has to describe the system inside the electron's accumulation by mathematical entities which are as much as possible faithful to reality. In the frame of quantum theory of fields, whereas from the pure theoretical point of view, people are free to choose, for example, the gauge group, which ensures success in any way of theoretical magnetic monopole creation without the other requirement. You can hear me okay, Steve?
Yep. Yeah, you betcha. Doing great.
Let's go on keeping the hypothesis that the electrons, which constitute a transitory accumulation, are initially taking part of LPS, a quasi-free, as it has been mentioned before. What does LPS stand for again, Eddie? So,
LPS is So, no, it's buried. Sorry. Just
Okay,
carry
well,
on.
they can look earlier on.
Yeah.
They are quasi-free, as it has been mentioned before. Considered from the quantum field theory point of view, Hamiltonian some x site remains quasi-constant as long as it is not x, meaning I think distance, linear distance. Site remains quasi-constant as long as as it is not submitted to a local interaction, particularly to the field gradient around two colliding nuclei. From a pure experimental point of view, as long as the spatial distribution of electrons is sufficiently loose for neglecting interaction, a gauge group G is ruling the space structure at this specific x, meaning probably distance, place. Apparently, for describing a non-interacting electron, interacting electron, one has to take into account only the rotations. No matter is no matter is the interval between electrons. One can suppose they don't interact. The evident choice is thus SO3. That's like particle physics, the kind of system that they're operating under. The often related to things like string theory or electroweak, that kind of thing. Continuous group of all proper, so that's a mathematical group that is used to solve SO3 is a mathematical group. The
Yeah.
continuous group of all proper rotations in 3D Euclidean space. The Hamiltonian H.
Sorry, LPS was large Poincare system.
Large Poincaré system.
Yeah, point point Poincare system. Yeah.
Hamiltonian H of two electrons constituting a non-interacting system is the sum of the Hamiltonian H1 and H2 of two electrons. So Hamiltonian is like quantum mechanically is like I think it's the quantum mechanical mathematical framework, a mathematical symbol. I think it relates to energy in the quantum system. I have to check it up though. So of two electrons is H was H1 plus H2. The Hamiltonian is the way that in quantum mechanics you formalize describing things like particle motion and
Okay.
energy like that. Thus, G, the gauge group, is the product of the combination law between the two elements of the SO3, which is to do with rotation and the mathematical group. G equals SO3 times SO3, equation 5. When the electron accumulation is sufficiently formed, the gauge symmetry breaking occurs. The only invariance means doesn't change under rotation or under motion or rotation. Invariance means not changing.
Yeah.
Because the only invariance which remains is ruled by SO3 alone, subgroup of SO3 times SO3. There are two causes for gauge breaking. Firstly, the repulsive Coulomb forces of the negatively charged electrons. Secondly, the spin-spin interaction, whose range is shorter, reference 5 to 6. According to the general scheme, topologically non-trivial field configurations are classified according to the second homotopy group I to the two, I underscore 2 in brackets G over so 3. Moreover, in this specific case, one has the equality 6, so 3 being considered as containing U1 of electromagnetism, reference 4. So I underscore 2 in brackets G over O3 close brackets equals pi underscore 1 in brackets SO3 equals Z underscore 2. So underscore 1 is the first first homotopy group. As given equation 5, there is, in this case, one specific sort of monopole with the first, the second homotopy group being identical. In this process, one unique sort of monopole is produced, corresponds to the element -1 of Z underscore 2. Okay, we're going. This case involving the electron accumulation is thus different from the one considered by Hoft and A.M. Polyakov, reference 15. According to their model, magnetic monopoles, which are considered being extended field configurations, reference 14, arise when a simply connected group G is broken to the U1 group, mathematical rotation group, whatever that represents, of electromagnetism. The typology relationship between homotopy groups is different from the preceding one. Pi underscore 2 in brackets G over U1 group equals pi underscore 1 in brackets U1 equals Z, equation 7. Z is the group of addition of positive and negative numbers. It means that the topological effect, which constitutes the monopole, may be considered as being made of an infinity of curves, reference 15. One shows that such a magnetic monopole carries a quantum number nu, which is an integer, positive or negative. I just want to see how far this goes on for. Okay. This eta number is called the winding number. The group structure of Z shows that this eta quantum number is conserved. Thus, in the 't Hooft case, two monopoles can fuse together to form a monopole whose quantum number is the sum of the two quantum numbers, eta is eta prime. As for the magnetic moment G, it is proportional to the winding number and inversely proportional to the electric charge. It is given as G equals minus in brackets eta over E, close brackets, alpha, equation 8. Alpha being the fine structure constant of particle physics. In our case, magnetic monopole creation by electron accumulation, there is only one sort of monopole which can annihilate only in pairs. The absolute value of G is unique. G equals in brackets 1 over E. I think that E is the electron charge. I think that's the charge on an electron. So G equals in brackets 1 over E multiplied by alpha, the fine structure constant, equation 9, whose relationships giving G are somewhat in agreement with the point of view of Dirac, who demonstrated with the help of the classical formalism and supposing each pole to be at the end of the unobservable string at G equals minus in brackets nu over E, close brackets, alpha over 2. equation 10. In fact, various experiments show that the multiplying factor should be alpha, which is the fine structure constant, over 6, value quoted in reference 16. Proof, proof, to prove the monopole existence in the most direct and convincing way consists of using Dirac equation, which has as a particle physics equation, Dirac equation, which has been primitively devoted to describing relativistic electrons. I think it was involved in relativistic quantum mechanics, which is not to do with relativity and quantum gravity. Relativistic quantum mechanics is just to do with quantum mechanics at the speed of light. It's not to do with gravity and quantum mechanics merging.
Mm-hmm.
To do with special theory of relativity, not general theory. As it has been shown by G. Lokac, this equation emits not only one local gauge invariance, two and no more, reference 16. Moreover, the magnetic monopole could be a magnetically excited neutrino. This way does not seem to give the possibility to describe any monopole creation channel. Energy and mass. De Hooft and Polyakov utilize a relativistic Lagrangian density. The Lagrangian is just another mathematical formalism for dealing with particle physics to get an evaluation of the monopole energy and mass. This Lagrangian is useful in the domain of particle physics. We obtain for the mass m underscore m equals brackets 4 pi over speed of light squared c squared, close brackets m underscore w c brackets beta, equation 11. C beta depends not much on beta. It varies between 1.1 and 1.4 for 0.1 less than beta less than 10, reference 14. M underscore W is the mass of the intermediate vector boson. The boson is a communicator particle like the photon or the Z particle or something, or the gluon in particle physics. And M underscore M is approximately equal to 137, which looks like the fine structure constant. I'm not sure about that. But M underscore M is approximately equal to 137 M underscore W. That sounds like the weak particle. I'm not sure. The weak force or whatever. In the case of the monopole creation by electron accumulation, the Lagrangian density is surely different, largely lesser than 137 M underscore W. If one considers typical new electron number equal to 10 to the power 4, the accumulation, for example, necessary energy for building an electron accumulation, typically in the range of some tens of kilo electron volts to 100 electron volts. For a 50 giga electron volt, typical value of the intermediate boson mass, the boson is a communicator particle, a bit like the photon. Or photon is an example of a boson. Bosons in other forces. The ratio between the two qualities of energy, one of the device, other of the monopole mass, is in the range of 10 to the power 7. This discrepancy is evidently an elementary evidence that the mass of the monopole energy are much lesser in the case of an electron accumulation. Thus, the choice of a Lagrangian density is primordial. Computing mass, but primordial for computing mass and energy in the case of monopole creation, electron accumulation. It will deserve specific calculation. Small bursts of magnetic monopoles. I'll just read that again. So, thus, the choice of the Lagrangian density is primordial for the computing mass and energy in the case of a monopole creation of electron accumulation will deserve a specific calculation. Possible bursts of magnetic monopoles. By the way, one has mentioned that it is possible to get experimentally an important magnetic monopole number if they are generated in electron accumulations, which are on sites of the two nuclei collisions. Supposing it is so, each electron accumulation would prompt a magnetic monopole. With this hypothesis, n being the number of electrons per unit volume, in brackets mu squared n over 2 is equal to the magnetic monopole number, which are generated in the volume unit. This volume being supposed turned into a unique LPS. What is it? Large particle scale?
A large Poincare system.
Large Poincare system.
Yeah.
As a mathematician. Okay, for example, mean number of nucleon of V volume reads V equals 4 radius to the power of 3, which equals 0.529 times 10 to the minus 8 centimeters brackets cubed. N equals 10 to the power of 22 nuclei per centimeter cubed. Mu equals 10 to the power of minus 3. E to the power of minus mu is approximately equal to 1. Nu is equal to 2 times 10 to the 3. N equals 10 to the 23 nuclei per centimeter cubed. Nu equals 2 times 10 to the minus 3. E to the minus mu, e to the minus mu, approximately equal to 1. Nu is equal to 10 to the 3. In brackets, nu squared n over 2 equals 2 times 10 to the 17. So we're coming to the end of this in a moment.
Yep.
Suppose the magnetic monopole generation is taking place during trailing edge of a pulse current, like the case where an electron accumulation prompts fusion reactions by lowering the Coulomb barrier. One gets what one can call a burst of 5 times 10 to the 15 minus 2 times 10 to the 17 magnetic monopoles per cubic centimeter.
Interesting.
One has to emphasize on the hypothesis, whole volume must be the whole volume must be supposed to be turned into a large particular system. Oh, yes. That every electron accumulation prompts a magnetic monopole. Experimental evidences. We dispose of two kinds of results. Firstly, ones relating the working of electron accumulations, screening device for lowering Coulomb barrier and prompting low energy nuclear reactions. Secondly, the ones relating its working as magnetic monopole creation. One has to emphasize on the fact that results one has at this time are pointing out that one gets in an equal footing low energy nuclear reactions and bursts of magnetic monopoles. One succeeds to create in a condensed medium what we have called large particle system, reference 5 to 6. Systematic experiments will still necessarily systematic experiments are still necessary to understand if there could exist a probability of magnetic monopole production versus a low energy nuclear reaction probability, and perhaps a simultaneous production which one has no reason to exclude. From the pure experimental point of view, one can only put forward the fact that transmutation and atom level energies is used, or I think that's not spelled. From a pure experimental point of view, one can only put forward the fact that transmutation at atomic level energies is used to show up when a capacitor bank is discharged through a metallic foil at a volume of liquid connected in serial. The liquid can be ordinary tap water. It has been sufficient to use a 4.8 kilovolt 50 kilojoule. Is that 0 or O?
I think that's 50 kilojoule capacity.
50 kilojoule capacitor bank. So one can use a very simple experimental device. The simultaneous occurrence of atom level transmutations of a plasma-like sphere or ball lightning is the mark of a well-working experiment. Reference 7 to 11 and 17. It's relatively simple also to detect transmutations picking up the remains of the foils inside which it occurs atomic energy transmutations, and to analyze them afterwards in mass spectroscopy. It seems, given their creation process, that the interaction of magnetic monopoles with matter is rather different from the one with charged particles. The simple use of nuclear films has been sufficient during the first experiments to estimate the process completely. So during the first experiments to estimate that the process is completely repetitive. Reference 7 to 11. Conclusion. A simple analysis confirms that the process of magnetic monopoles creation is possible in a laboratory concurrently with low energy nuclear reactions production. This possibility is new in the magnetic monopole hunting. In fact, for putting the device into condition, one would need only to ionize condensed medium to initialize a LPS, a large particle system, to let electrons crowd together. The particle physics would benefit from a low energy device of a condensed medium with the experimental possibility. So I'll read that again. So particle physics benefit from a low energy device of a condensed medium with new experimental possibilities.
Cool. And you don't have to go through all the references, but maybe just do the ones that I highlighted.
Okay. The highlighted references, reference 2, Ken R. Shoulders, EV, A Tale of Discovery, Austin, a historical sketch of early EV work available from the author. Okay, that was Ken Shoulder. I think that was Ken Shoulder's email address.
Yep, yep.
KR Shoulders, US patent. There's numbers there. Ken
Yeah,
Shoulder,
which we're going to go through all of those. I have all of those from Chris.
Ken Shoulders and Steve Shoulders. Observation on the role of charge clusters in nuclear cluster reactions. Journal of New Energy, Volume 1, Number 3, 1996.
We should look for that at some point. I'm going to try and do that maybe. That looks like a good one.
And reference 6, Rambot, electron clusters and nuclear fusion, colloquium. I think that's the kind of meeting of people, colloquium.
Yeah.
It's like a conference or something. Is transmutation possible energies of atomic levels? Paris, 26th to 27th of November 2003. 15. G. Hoft, magnetic monopoles in unified gauge theories, nuclear physics, P79, 1974, pages 276 to 284. A.M. Polyakov, JETP letters 20, 194, 1974. 16. G. Lockback, symmetry between electricity and magnetism and the problem of the existence of a magnetic monopole. Advanced electromagnetism, foundations, theory, and applications. Editors, Terence Barrett and Dale Grimes, Scientific, World Scientific, 1995. Okay, so
Cool. That's that. That's very cool. Does anybody have any questions or comments? I think that this magnetic monopole is one of the most important things, and it's kind of like a holy grail of physics again, kind of like the electrogravitic coupling that Paul Violette found. Yeah, so maybe we can end the recording if no one's got any comments, Brendan.
okay, so thank you everyone for watching. I hope you have a wonderful rest of the day. Cheers and bye.
Yeah, thank you.